YouTube has removed the dislike counter, but the numbers are still available backstage. And I can tell you that my most disliked videos, by far, are those on climate change. Doesn't matter if it's good news or bad news, some people, it seems, reflexively dislike anything about the topic, every time. And to be honest, I can kind of understand that. It's a little tiresome, isn't it? Climate change, extreme weather, heat records, blah, blah, blah. We've heard this for so long, and look, we're still here. Stop talking about it already. I get it, and I'd rather just talk about some fun new physics stuff. But I feel like I need to tell you about this, because the lives of hundreds of millions of people depend on it. Climate scientists are having an argument about a number. One single number called the climate sensitivity. I don't like what I've read, it really worries me, and I think you should know. I know you expect me to be funny haha, not funny peculiar, but I'm afraid this video will be more on the peculiar side. Why does Sabine worry about climate change, and why now? That's what we'll talk about today. 2023 was the hottest year on record since the beginning of records in the mid-19th century. Not just the average temperature increased to never-before-seen levels, in many places heat waves were also longer and hotter than ever before. In February, Antarctic sea ice reached an absolute record low since the beginning of satellite measurements in 1979, and global ocean temperatures reached a new record too. I don't know about you, but to me that sounds pretty bad. Now, it's possible that 2023 was somewhat of an outlier and average temperatures will somewhat decrease in the next few years. There are several reasons for this. First, there's just regression to the mean. But second, there's also that in 2023 we switched from a La Niña to an El Niño phase. The La Niña-El Niño phases are quasi-periodic global climate patterns. These phases switch somewhat irregularly, but roughly every 2 to 3 years, and the El Niño phase that we just switched to is typically somewhat warmer. So next year might break more records because it will still be El Niño, but in 2 to 3 years we might see a slight cooling. And third, some researchers have speculated that part of this year's warming might have to do with the decrease in pollution over the oceans caused by new regulations of ship exhausts. It's somewhat unclear how large this effect is, but we do know that air pollution does indeed have a cooling effect, so maybe that's part of the reason. Be that as it may, I worry that even if 2024 is not a new record breaker, the overall trend in the next few years will be steeply up and the situation is going to deteriorate rapidly. The reason is to do with a quantity called climate sensitivity. Climate sensitivity, contrary to what you might think, is not what makes people hit dislike on climate change videos. It's a property of climate models. It's the temperature change that one finds in a model when one doubles atmospheric carbon dioxide over the levels of pre-industrial times and then waits for the system to come into equilibrium. In the literature, it's called the equilibrium climate sensitivity, ECS for short. This equilibrium climate sensitivity isn't something we directly observe because no matter how much they dig in Saudi Arabia, in reality carbon dioxide levels don't suddenly jump by a factor 2. However, it's a useful quantity to gauge how strongly a model will react to changes in carbon dioxide. And this climate sensitivity is the key quantity that determines the predictions for how fast temperatures are going to rise if we continue increasing carbon dioxide levels. Up to 2019 or so, the climate sensitivity of the world's most sophisticated climate models was roughly between 2 and 4.5 degrees Celsius. These big climate models are collected in a set that's called the Coupled Model Intercomparison Project, CMIP for short. That's about 50 to 60 models and is what the IPCC reports are based on. So until a few years ago, we had a climate sensitivity of 2 to 4.5 degrees or so, and that's what we came to work with. That's what all our plans rely on, if you can even call them plans. You've probably all seen this range in the IPCC projections for the temperature increase in different emission scenarios. It's this shaded region around the mean value. Loosely speaking, the lowest end is the lowest climate sensitivity, the highest end is the highest climate sensitivity. Then this happened. In the 2019 model assessment, 10 out of 55 of the models had a climate sensitivity higher than 5 degrees Celsius. That was well outside the range that was previously considered likely. If this number was correct, it would basically mean that the situation on our planet would go to hell twice as fast as we expected. Okay, you might say, but that was 5 years ago, so why haven't we ever heard of this? What's happened is that climate scientists decided there must be something wrong with those models which gave the higher climate sensitivity. They thought the new predictions should agree with the old ones. In the literature, they dubbed it the hot models problem, and climate scientists argued that these hot models are unrealistic because such a high climate sensitivity isn't compatible with historical data. This historical data covers many different periods and reaches back to a few million years ago, back then when we still used dial-up modems. It's called the paleoclimate data. Of course, we don't have temperature readings from back then, but there's lots of indirect climate data in old samples, from rocks, ice, fossils, and so on. In 2020, a massive study compiled all this paleoclimate data and found that it fits with a climate sensitivity between 2.6 and 3.9 degrees Celsius. And this means implicitly that the hot models, the ones with the high climate sensitivity, are not compatible with this historical data. As a consequence, the new IPCC reports now weigh the relevance of climate models by how well the models fit the historical data. So the models with the high climate sensitivity contribute less to the uncertainty, which is why it has barely changed. And that sounded reasonable to me at first, because if a model doesn't match with past records, there's something wrong with it. Makes sense. Then I learned the following. The major difference between these hot models and the rest of the pack is how they describe the physical processes that are going on in clouds. A particular headache with clouds is the supercooled phase of water. That's when water is below the freezing point but remains liquid. The issue is that the reflectivity of the clouds depends on whether it's liquid or not, and that supercooling makes the question just exactly what influence the clouds have very complicated. But how much data do we have about how clouds behaved a million years ago? As you certainly know, the dinosaurs forgot to back up their satellite images, so unfortunately all that million-year-old cloud data got lost and we don't have any. To use the argument from historical data, therefore, climate scientists must assume that a model that is good for clouds in the current climate was also good for clouds back then, under possibly very different circumstances, without any direct data to check. That seems to me a very big if, given that getting the clouds right is exactly the problem with those models. Wouldn't it be much better to check how well those models work with clouds for which we do have observations? Like, the ones that we see in the sky. In principle, yes. In practice, it's difficult. That's because most climate models aren't any good as weather models. While the physics is the same, they're designed to run on completely different timescales. You make a weather forecast 2 weeks at most. But climate models, you want them to run 100 years into the future. There's one exception to this. There's one of the hot climate models that can also be used as a weather model with only slight adaptations. It's the one from the UK Met Office. So a small group from the UK Met Office went and used this hot model to make a 6-hour weather forecast. They compared the forecast from the hot model with the forecast from an older version of the same model that didn't have the changes in the cloud physics and was somewhat colder. They found that the newer model, the hotter one, gave the better forecast. And just so we're on the same page, when I say the forecast was better, I don't mean it was all sunny. I mean it agreed better with what actually happened. And that model with the better predictions had a climate sensitivity of more than 5 degrees Celsius. I know this all sounds rather academic, so let me try to put this into context. The climate sensitivity determines how fast some regions of our planet will become uninhabitable if we continue pumping carbon dioxide into the atmosphere. The regions to be affected first and most severely are those around the equator in Central Africa, India and South America. That's some of the most densely populated regions of the world. The lives of the people who live there depend on that scientists get this number right. So we need this number to get a realistic idea of how fast we need to act. That the climate sensitivity might be considerably higher than most current policies assume is a big problem. Why wasn't this front page news? Well, quite possibly because no one read the paper. I didn't either. As of date, it's been cited a total of 13 times. I only know about this because my friend and colleague Tim Palmer wrote a comment for Nature magazine in which he drew attention to this result. He also asked other researchers to try and do similar tests with other models to see how well they perform with the short-term weather forecast. Unfortunately, no one listened to him. That includes me, because I have better things to do than read all of Tim's comments. Sorry, Tim. And in all honesty, I had pretty much forgotten about this. But then late last year, a new paper with Jim Hansen as lead author appeared, which reminded me of this. The new Hansen et al. Paper is a reanalysis of the historical climate data. In a nutshell, they claim that the historical data is compatible with the climate sensitivity of 4.8 plus minus 1.2 degrees Celsius. That agrees with the hot models. And if it was right, it'd invalidate the reason that climate scientists had to dismiss the models with the higher climate sensitivity. I don't want to withhold from you that some climate scientists have criticized the new Hansen et al. Paper. They have called it a worst-case scenario that is quite subjective and not justified by observations, model studies or literature. Though it isn't irrelevant to note that the person who said this is one of the authors of the previous paper that claimed the climate sensitivity from historical data is lower. I don't know who's right or wrong. But for me, the bottom line is that the possibility of a high climate sensitivity above 5 degrees Celsius can't be easily dismissed, especially not seeing how fast average temperatures have been rising in recent years. And that's really bad news, because if the climate sensitivity is indeed that high, then we have maybe 20 years or so until our economies collapse. And what's the point of being successful on YouTube if my pension savings will evaporate before I even retire? This isn't in the script, but it just blows my mind how mind-fuckingly stupid it is that the lives of all people on this planet depend on an obscure discussion about the properties of supercooled water droplets in a type of cloud whose name I can't even remember. And that returns me to the people who reflexively dislike any video on climate change because they really don't want to hear about it. I believe that most of them aren't actually climate change deniers. I think they just can't see how it's going to affect them. What's the big deal with a few degrees temperature increase? We'll just turn up the air conditioning, right? I think it won't be that easy. Which is why I now want to spend a few minutes telling you what I think will happen in the next 20 years or so. The next minutes of this video will be quite depressing. And if you're struggling with anxiety, I sincerely think it'd be better if you stopped watching here. Did I just tell people to not watch my videos? I'm not doing this YouTube thing right, am I? If you're still with me, here we go. Earth has 5 different climate zones, and each has its own typical type of vegetation. If climatic conditions change rapidly, a lot of plants will not grow properly or die because it's too hot or too dry or too wet or all of the above. Yes, plants like carbon dioxide, but that isn't going to make up for the much bigger problem of the rapidly shifting climate zones. And yes, we can try to genetically engineer plants that are better adapted to the new circumstances, but that's That's going to take time. And time is exactly what we don't have if the climate sensitivity is really as high as the hot models say. People in the developed world somehow cope with the hotter conditions by fertilizing and irrigating the hell out of any agricultural areas they have. But in many countries around the equator, crop yield will substantially drop. This will most affect countries that are already prone to famine, and at the same time, some of the poorest countries in the world will be hit very hard by heat waves and drought. I don't think that a human right for air conditioning that some people argued for in a Scientific American article is going to make much of a difference. Okay, so we have famine and drought and heat waves, but it's just, where poor people live. It isn't really our problem, right? Well, that's not the end of the story, because those poor people who don't conveniently die right away will draw consequences. They'll leave. We're talking about some 100 millions of people who have nothing left to lose, suddenly beginning to migrate. Where will they go? Most of them will go north. Why? Just because there's more land north of the equator than south. That's going to cause a lot of tensions at the southern borders of Europe, Russia and Mexico, for just to mention a few. Someone somewhere will make a lot of money by selling weapons. Drones will be deployed. Some of them will shoot. Innocent people will die. But wait, that's not it. Because death and migration make a great breeding ground for new viruses, bacteria and fungi, so chances are we're going to get a new pandemic along with it. So we have widespread crop failure, high numbers of people dead, mass migration, political tensions and possibly war, likely public health disasters. Meanwhile, people in the developed world are scrambling to adapt, moving inland as seawater levels continue to rise, trying to install air conditioning wherever they can, and are giving up pretending to cut back carbon dioxide emissions, which is going to speed up the further proceedings. The result will be an enormous economic downturn. The practical consequences for you and I will be that everyday products will become more and more expensive until most of us simply can't afford them anymore. And then they'll disappear. Need a new phone? That'll be $50,000. Internet connection at home? $8,000 a month. Want a new microwave? Sorry, we're all out of stock. Need someone to fix your roof? We're short on staff. They're still cleaning up the mess from the recent flood. In simple terms, the problem is that there's only so much work one person can do in one day. And if we're busy trying to survive, everything else will go on pause. People who are busy building air conditioning units are people who are not pushing the cutting edge of nanotechnology. I don't think we'll go extinct. There's just too many of us, and I don't think civilization will entirely collapse, because much of the infrastructure we already have is going to last until the worst is over. But it's going to be a phase of regress rather than the progress that we've become used to. It's going to be really unpleasant, will quite possibly reduce the world population by a few billion, and it's not a world that I want to live in. And no, AI isn't going to solve the problem, because the problem isn't that we're missing a technological solution. The problem is that we can't agree to implement the solutions that we have. You probably expect me to end on some recommendations. I don't think it matters much what I recommend, but I also don't want you to go away complaining that I haven't thought about it. So here's my wish list. Put a price on carbon dioxide emissions now. Continue to expand renewables. Build nuclear, build nuclear, build nuclear. Stop bitching about carbon dioxide removal. There's no way around it. And for heaven's sake, stop gluing yourself to things. Now, I'm not asking you to like this video. I don't really like it myself. Thanks for listening. We'll be back next week.